Now we're going to prove the following result. -1 times -1 is 1, or -1 times -1 is 1. We're going to prove this result in R. Okay? So we know the exponent. So if some number, some x is raised to some a, we know that if a is in n, we know that this is x times x times x 8 times. Okay, we expanded this result to a being in R. Okay, here to prove this result, we can use something that we know. Okay, so we're gonna define a function, okay, from R onto R plus, such that for each x it does associate x squared. So we are defining f of x as x squared. Okay, so -1 is in R. Okay, it's an element in R. And using this function here, we know that f of -1 is just 1. Okay, okay, if you are not convinced, you can argue that this function is even, and for each x, f of x is minus f of x. Okay, and therefore f of 1 is just f of -1. But we know that f of 1 is just 1 squared, which is 1. And therefore f of -1, which is -1 squared, is 1. And by definition of the exponent, this is just -1 times -1, which is 1. Okay, so this is one way of proving this result. And we see that we have in R -1 times -1 is 1. Okay, in complex there are many other ways, but we restrict ourselves to just the set of real numbers. Okay, there is another way that we can do this one. We can prove it using the axioms in R. Okay, the axioms that we accept as true in the set of real numbers. For instance, we have 0 plus x is 0, and we have 1 times x is x. And also we have x plus minus x is 0. Okay, so we can start from here and we can prove this result. But this is enough using this function here, because this multiplication is basically doing the using the image of this function here, the image of this element, which is -1. Okay, so this shows using this simple function that -1 times -1 is 1. Okay, if you want to prove it, you need to know more about the axioms, okay, and arrive at this result. Okay, thank you very much.